In this video, we'll be covering Chapter 8, Section 4 on compound interest. This one is on our reference sheet, so if you notice 8.3 was here, this will be 8.4 formulas. Compound interest is different from simple interest because now we have a number of compoundings per period in that time. So A is going to be equal to our principal, parentheses, 1 plus our rate divided by the number of compoundings, all of that raised to the number of compoundings, the amount of time. A is still going to be our future value, P is going to be our principal, R is still the rate expressed as a decimal, but it will be given to us as a percentage. T is typically time in years, and the N is the number of compoundings in a year. Let's look at an example. You deposit $1,000 in a savings account at a bank that has a rate of 4%. We're going to find the amount, A, future value, of the money in the account after 5 years. We use our compounding interest formula. And let's go ahead and write down our variables. We're put down 1,000, so that will be our principal. The rate is 4%. Since it does not say how many compoundings we have, we always assume 1. Our T will be the number of years, in this case 5. Let's go ahead and plug in our values. P is 1,000, parentheses 1 plus our interest rate is 4% divided by 1. Raised to the 1 times 5. When you put it in the calculator, you want to make sure to use the parentheses as you see them here. I'm going to go ahead and put 1,000 parentheses 1 plus 4%. Okay? I'm not going to divide it by 1 since I know 4% divided by 1 is going to get me 4%. Close the parentheses, and now I'm going to raise it. This part is important. You want to make sure to include parentheses. Anytime you have it raised, you want to make sure to use your parentheses, because if you do not, it will raise this value only to the very first value and then times everything by 5. You need to make sure to keep the order of operations correct. You press enter, and we get our future value of $1,216.65. Because the number next to the 5 is a 2, which is less than 5, we keep that 5 exactly the same. Part B says to find the interest. We're going to start with the future value, and we're going to subtract the amount of money we put in this case $1,000. That means the interest we made is going to be $216.65. Example 2 says you deposit $4,200 in a savings account that has an interest rate of 4%. The interest rate is compounded quarterly. How much money will we have in 10 years? We're going to round to the nearest cent. So what we're looking for is our future value, which we don't know. The principal is the amount you put down, which is $4,200. Interest rate is still 4%. T is going to be 10 years, and N will be 4. Think of how many quarters are in 1. Here's our same formula. Let's plug everything in. P, 4,200, parentheses, 1 plus 4%. Notice that I went ahead and divide this by 4. And it's raised to a 4 times 10. In this particular case, what I did was go ahead and do the part in the parentheses first, and then I multiplied the two exponents. Let's go ahead and do that. 1 plus 4% divided by 4. There's my 1.01. And then I just multiplied 4 times 10, which gave me 40. By doing this, I get 4,200 times 1.01 raised to 40. When I press enter, I get a value of $6,253.23. The 7 is greater than 5, so I raise that 2 up by 1 cent. I could also just put the entire value here into the calculator. 4,200 parentheses 1 plus 4% divided by 4, close the parentheses. When I raise it, however, I want to make sure to use parentheses in this case. 4 times 10, close it. When I press enter, you see that we get the exact same value, just make sure to round correctly. Part B says to find the interest rate after 10 years. So since we have our future value of $6,253.23, we need to subtract the initial amount that we put in, $4,200. Let's go ahead and do that. $6,253.23 minus $4,200. The interest we made in the 10 years was $2,053.23. The next part is talking about continuous compounding. Continuous compounding means that we are not compounding so many times in a year, but that we are doing it continuously. We use a separate formula for that. If you notice here, I have two compound interest formulas. The very first one includes the n because we're compounding in a specific number of times. We're either going to be using this equation here or we're going to be using this equation here. This equation indicates that it is a continuously compounding because you do not see the n. So that is this formula here. A still refers to our future value. P is still going to be our principal. R is going to be our rate in decimals, but always given as our percentage. T is time. E is going to be a value on the calculator similar to pi. If you look on your calculator, you will see your value E underneath your log button. Let's look at an example. A sum of $10,000 is invested at an annual rate of 8%. We're going to find the balance of the account after 5 years, subject to A, quarterly compounding. Anytime it gives you a specific number of compoundings, we are going to use the compounding equation that has the value of n. Let's go ahead and determine our variables. A is what we're trying to figure out our future value. P is the amount that we invest, which is $10,000. R is going to be 8%, and quarterly, that means 4. T will be the number of years, in this case 5. So let's plug in our values. 10,000 parentheses 1 plus 8% divided by 4 raised to 4 times 5, 20. I wrote the information down here, but I'm going to go ahead and show you how to do the exact formula into the calculator. We're going to do 10,000 parentheses 1 plus 8% divided by 4, close the parentheses. Use your caret, which is here, and then a set of parentheses for your exponents. 4 times 5. When you press enter, you see you will get 14,859.47. If you notice the number next to the 7 is a 3, which is less than 5, which means you do not round your 7 up to an 8. You can also go ahead and break it down as I showed here, where I did 1 plus 8% divided by 4, and I got the 1.02, which is here. 4 times 5 is 20, which is my power there. If you put this into the calculator, you will get the exact same value. When we're looking at continuously compounding, we'll be using that second formula. P is still going to be 10,000, E raised to R, which is 8%, for still 5 years. Let's go ahead and put this one in the calculator. I'm going to start off with my principal, which is $10,000. E is going to be located right here next to the natural log button. We're going to hit the second first and then the LN. That will give us the E. Notice that it automatically gives us a set of parentheses, and here we're going to go ahead and multiply 8% times 5 years. Close the parentheses and you get $14,918.25. The 6 is greater than a 5, so that means the 4 goes up to 5. The next section is over present value. This is our formula for our present value. If you look on your compound interest, it's going to be the very next equation going down. Present value means that if we are given a future value and we know the interest rate and the number of compoundings a year for so many years, we can determine how much we need to put in right now. Let's look at an example. How much money should be deposited today if the account earns 7%? That's going to be my R. Compounded weekly. We need to determine how many times it will be compounded in a year. Since there are 52 weeks in a year, we can say that N is equal to 52. So that it will accumulate $10,000. So that's going to be our future value. So I put A is equal to 10,000 in 8 years. So T is equal to 8. We use our formula and let's plug in our values. A is 10,000 divided by 1 plus R, which is 7%, divided by 52. That is raised to 52 times 8. Let's go ahead and plug this into the calculator. I'm going to go ahead and enter the entire equation into the calculator to show you that you can go straight to your answer. We're going to start with 10,000 and we're going to divide that by parentheses 1 plus 7% divided by 52. Close the parentheses and then you're going to raise that. Remember, open a new parentheses for your powers. 52 times 8. Close the parentheses and then you can press enter. You will get a value of $5,714.25. In this particular case, we round up our value to 25 cents because if we put in 24 cents, we will not get the amount of $10,000. So it doesn't matter what the value next to that 4 is when you're calculating our present value. Always round up to the next cent. If you don't feel comfortable entering the entire equation into the calculator, you can break it up. However, you need to store your information into the calculator to get the exact value. Any kind of rounding will make your answer incorrect. I'm first going to start by multiplying 52 times 8. Here we get 416. Now I'm going to go ahead and calculate the information inside the parentheses. So I have 1 plus 7% divided by 52. When I do this, I get this value I have written here. Notice now I'm going to keep the answer in here and specifically raise that answer to 416. Do not just put 1.00134 into your calculator and raise it. That would get you an incorrect answer. Once you raise that answer, you will have another number, which I have here. Notice those 3 little dots means that it will continue forever and ever and ever. What I'm going to do now is make sure I keep this answer here, or you can go ahead and store it. If you store this answer, go ahead and pick a value you want to store it in. We'll store it in A. Okay. Now I'm going to take my 10,000 and I'm going to divide it, and I'm going to recall my value A. So in order to recall, you need to press your second store button, and then you pick the value that you stored it in. I chose A, so I'm going to pick A. It will automatically enter that number into the calculator, and then when you press enter, you get the exact same value that we had before. This next section is over the effective annual yield, or in other words, an effective rate. This is the simple interest rate that produced the same amount of money at the end of 1 year as when the account is subject to compounding interest at a stated rate. What we're doing here is trying to determine what the simple interest would be if we had invested our money in a simple interest fund instead of a compound interest fund. Let's look at an example. Here you deposit $6,000 in an account that pays 10% interest compounded monthly. We're going to find our future value after 1 year. So P is equal to 6,000, R is equal to 10%, and our time is 1 year. Our N will be monthly, so how many months do we have in a year? N will be 12. We're using our compounded interest formula here. Plug in our values, 6,000 parentheses 1 plus 10% divided by 12 raised to 12 times 1. I'm going to go ahead and enter it into the calculator. 6,000 parentheses 1 plus 10% divided by 12. We're going to raise that and add your parentheses. 12 times 1 is just 12. When I press enter, I find that I will have a future value of $6,628.28. Because the 8 is greater than 5, we round that 7 up by 1. Okay. Now we will determine what the effective annual yield would be. What we're trying to do here is determine what our interest rate would be had we had a simple interest formula. So we're going to start with our simple interest formula here. Our A is going to be the amount we found in part A, equal to P is still going to be 6,000, 1 plus R. Remember, in this case, it's a simple interest rate, and this one was used for our compounding interest. Since we have a different interest rate if it was simple, we're going to leave this value as a variable. First thing I'm going to do is divide by 6,000, which cancels these two out. Let's go ahead and put this part in the calculator. 6,628.28 divided by 6,000. We get a value of 1.10471 ... is equal to 1 plus R. Subtract 1 from both sides, and now we have a value of 0.1047. Remember that this is a decimal. To change it to a percent, we have to multiply by 100. So our interest rate here would be 10.5%. Because the 7 is greater than 5, we're going to round that 4 up by 1 value. To make things simple, we could have used this formula here to determine our annual effective rate. Let's go ahead and plug in these numbers. We have parentheses 1 plus our interest rate for our compounding is 10%. So I'm going to put 10% here. Divided by N, which is 12. So divide by 12. Close the parentheses and raise it to a power of N. So I'm going to raise this to 12, And then I'm going to subtract a 1. Notice here I did not use parentheses for this part because the order of operations would raise this value to 12 and then subtract 1. If I press enter, I get our decimal value, and to get this into a percent, I need to times it by 100, which is exactly the same value I had down here. Example 6 says, what is the effective annual rate of an account paying 8% compounded quarterly? Our N in this case is going to be 4 since there are 4 quarters in 1 year. Okay. Just plug in your values that you were given again. 1 plus 8% divided by 4 raised to the 4th minus 1. Plug it in exactly as you see it. 1 plus 8% divided by 4 raised to the 4 minus 1. When you press enter, you'll get the decimal form, and remember to multiply that by 100 to change it to a percent. So here we have 8.24%. That concludes 8.4. If you have any questions, please let me know.